Hi, I'm going to show you in this demonstration how to very efficiently calculate descriptive statistics using the Data Analysis Toolpak on the PC version of Excel. I'm going to assume that you have already installed the Data Analysis Toolpak. If you haven't, please refer back to a previous video. Let's say I'm interested in calculating descriptive statistics here on characteristic 3 in column D. I might go about that by finding the Data Analysis button that's on my Data tab over here. So I click Data Analysis. I am interested in descriptive statistics, which already happens to be highlighted. I click OK. My input range, well, I'm interested in column D. I'll input column D by clicking the box, highlighting D, then re-clicking the box. Yes, I have labels in the first row, so I want to ensure that that is checked. And I'm going to click Summary Statistics as well. And then I click OK. I opted to have this table pasted into a new worksheet within my same workbook. And here it gives me a nice table. Let's start with the mean. The mean is 29.88. It also gives me other measures of central tendency. It gives me median and mode. And it's important to note that all three of these, especially the median and the mean, are somewhat close to each other because in a normal distribution, we would expect the mean and the median to be close to each other. And normality is an assumption of many tests that we do in social work, especially the t-test and the ANOVA, which we'll get to later. Let's move down here. I have my standard error. My standard error is calculated by dividing the standard deviation down here, 2.3003, by the square root of 50, i.e. the square root of my sample size. So count down here indicates my sample size. I also get an idea of how much variation there is in my sample by the range. The range is 11. My data extend from a minimum value of 25 to a high value of 36. And this is important to note when we go on to create our histogram to further inspect the normality or lack thereof of our data. Finally, let's hit up here on kurtosis and skewness. So kurtosis and skewness help us to describe the distribution of our data. In a perfectly normal distribution, the kurtosis would be 0, as would the skewness. I'm here a little bit different than 0, which indicates a slight departure from normality. It's difficult to ascertain in Excel versus SPSS whether this slight departure from normality is statistically significant or not. The differences in SPSS, alongside the kurtosis value, we would get a value right here in column C indicating the standard error, which would enable us to assess whether we thought that the departure from kurtosis was statistically significant. Here we're just eyeballing it. My kurtosis value is positive. That means it's going to be a slightly peaked distribution, peaked meaning it will be tall and skinny. If the value for kurtosis were negative, that would mean it would be a flat distribution. Down here in skewness, again, I have a positive value. That indicates that I'm going to have a slightly longer right tail in my histogram than the left tail. If the value were negative, then I would have a longer left tail. So, one last thing to point out here, I have variance, and variance is quite simply the standard deviation squared. And it is yet another measure of variation. Great, thank you.